In modern physics, semiconductors and communications, there are 19 question types that you should be very comfortable with to do well in JEE Main in this topic. So starting with the de Broglie wavelength of subatomic particles, here given the kinetic energy of the subatomic particle, directly or indirectly, you will be asked to determine the de Broglie wavelength of the particle using the relation lambda is equals to h by p, where h is the Planck's constant and p is the momentum of the particle, which is simply mv. And we can express kinetic energy k in terms of momentum p as p square by 2m, which means we can express wavelength lambda in terms of kinetic energy k as lambda is equals to h by square root of 2mk. Now at times questions might be asked on the order of uncertainty either in position or velocity of the subatomic particle, given its speed or momentum or kinetic energy, using Heisenberg uncertainty principle. Delta x times delta v is greater than or equals to h by 4 pi m. And remember that if the uncertainty is not given explicitly, say in velocity, you can take it to be of the same order as the magnitude of the velocity in the worst case. Hope that made sense, but do read through the notes and practice a few questions. In the next important question type involving AM modulation, here the examiner might want to check your understanding of the mathematical expression of the amplitude modulated wave, or they might simply ask you about the modulation index, which is simply AM by AC, that is amplitude of message signal divided by the amplitude of the carrier wave. Or they might simply ask for sideband frequencies, which are omega of the carrier wave plus minus frequency of the message or signal. And note that the bandwidth needed to transmit the signal or message is 2 times omega m. Read through the notes and solve few questions to make sure you are comfortable in solving these questions. In the next important question type involving radioactive decay, you will be expected to use the equation n is equals to n0 e to the power minus lambda t, with n being the number of nuclei left at time t, n0 is the population at time t equals to 0, and lambda is the disintegration constant. Note that half-life, which is defined as time it takes for half of the population to decay, is ln2 by lambda, and average life or mean life is the time it takes for the population to decay to 1 by e of the original population, and it is simply 1 by lambda. Read through the notes carefully and understand the different forms and how to use them effectively. Moving on, in the next important question type, you will be given circuits with different logic gates, and you will be expected to determine the output either in terms of 0 and 1, or as in Boolean expression in terms of inputs A and B, or in terms of the output waveform. Make sure that you read through the steps carefully, solve a few questions, and get comfortable with the 4 different ways questions can be posed on logic gates. In the following question type, you will be dealing with photoelectric effect and expected to use energy conservation equations. That is, energy of the incident photon, which is hc by lambda, is equal to work function of the target surface. That is, energy required to overcome the potential barrier plus Kmax, the leftover energy from the absorbed photon that shows up as the kinetic energy of the electron. Here, Kmax might be given in few different ways, so read through the notes and practice questions. Moving on, in the next important question type, you might be given circuits with Zener diodes, which are special purpose diodes that operate in reverse bias and act as open till voltage across them exceeds the breakdown voltage, after which they allow the current to pass through them. But now they maintain breakdown voltage across their terminals. If you understand this concept, then it will be fairly easy to understand the standard types of questions that are asked on such circuits as detailed in the notes. In the following question type, you will simply be asked to determine the maximum possible distance between transmitter and receiver antenna of given heights for line of sight communication, wherein we account for the curvature of Earth. Fairly simple and straightforward questions. In the next one, you will be dealing with circuits with ideal or silicon diodes, with only difference being the fact that when operating in forward bias, silicon diodes have a drop of 0.7 volts across the junction, and ideal diodes do not. Also note that in reverse bias, meaning P side is at lower potential than N side, no current will pass through the diodes and they act as open. For the rest, use your knowledge of Kirchhoff's law and junction rule to solve for the unknown. Moving on, in the next two important question types, you will be dealing with transistors. Remember that current gain beta is equals to collector current divided by base current, and 1 by alpha is equals to 1 plus 1 by beta. Voltage gain is simply minus beta times load resistance divided by input circuit resistance. And power gain is the product of voltage gain and current gain. In the next one, you will either be asked to determine the wavelength of the emitted or absorbed photon by a hydrogen-like atom given the initial and final states, or given the excited state, you will be asked to determine the number of wavelengths emitted or vice versa. Read through the notes and solve few questions. In the next one, you will be tested on your understanding of Lyman series, Balmer series and Paschen series. Remember that in Lyman series, all transitions involve n equals to 1. In Balmer, they involve n equals to 2 orbit and one of the higher orbits. And in Paschen series, they involve n equals to 3 and one of the higher orbits. Also note that in Balmer series, the first 4 frequencies involving n equals to 2 to n equals to 3, n equals to 2 to n equals to 4, or n equals to 2 to n equals to 5, or n equals to 2 to n equals to 6, they fall in the visible range. Higher frequencies are again in the ultraviolet range in the Balmer series. Paschen series involves wavelengths in infrared region. Moving on, in the next one, you will be tested on the basics of PN junction diodes. So read through the notes to get the important points. In the next important question type, you will be asked to determine the energy difference between different orbits of a hydrogen atom or hydrogen-like ions such as He plus or Li2 plus. Recall that energy of the nth orbit is given by minus 13.6 Z square by n square electron volts, or minus Z square by n square Rydbergs. Also note that in the nth orbit, kinetic energy is equal to the magnitude of the total mechanical energy of the electron in that orbit. That is simply 13.6 Z square by n square electron volt. Now also note that if the electron of say hydrogen atom in its ground state absorbs a photon of energy 15 electron volts, then 13.6 electron volts will be consumed in overcoming the electrostatic potential barrier, and remaining 1.4 electron volt will show up as the kinetic energy of the electron. In the next one, you will be dealing with either serial radioactive decay or a parallel radioactive decay. I would highly recommend that you go through the notes and understand how to write the rate equation and how to solve them. It involves a standard mathematical trick in case of serial decays. Moving on, in the next one, you will simply be asked questions around the dual behavior of light. Recall that light behaves as wave when traveling and behaves as a particle when interacting with matter, with wavelength lambda related to momentum of the photon by P is equals to h by lambda. And energy of the photon is given by hc by lambda, or momentum P times speed of light c. With that, now let's move to last two important question types on nuclear reactions and modern physics basics, for which I would recommend that you read through the notes and go through the questions to understand the nature of questions asked. With that, best wishes for questions on modern physics in JEE Main.